Hello dear students, I Ganesh welcome all of you to this session of plus 2 second year mathematics. We are already meeting 3 to 4 times in our previous classes, and now we are moving to the new type of topic of relation and function. The relation part is already over in our previous classes. Today we will move to the next topic, that is function. Clear? So today the topic of discussion is function. Now my dear students, you are already acquainted with function in our previous first year. Yes or no? In your first year you are acquainted with function, the basic concepts, that what is a function and how to find the domain, codomain and range, how to find the image of a function. Let us recap it in a quick manner and then we will proceed to the topic of second year. Okay, so already you know that function is defined what? Function, it is defined from a Latin word. It is defined function, some basic concepts of function, that function is defined. Function is derived from a Latin word. From a Latin word which means operation. Which means operation. The function is also called as mapping or simply map. Okay, so this is the two basic definitions, that function is derived from a Latin word which means operation, and it has also the synonym. Function is also called as mapping or map. Clear? Now we will move to that how a function is defined. Okay, you know function is in first year we know that function is a special type of relation. Function is a relation, but every relation is not a function. Okay, so next I can say function is a relation, but every relation is not a function. Okay, so you see, function is what? Function is a relation, but every relation is not a function. Okay, you see that function is a relation, but every relation is not a function. Now we will verify it. Let us check it what it means. You see, suppose one set is there, set A containing the elements 1, 2, 3, and suppose there is a set B containing the element 4, 5. Okay, now you see what is A cross B. So it is 1, 4. Already we know how to find the product set. It is 1, 5, then 2, 4, 2, 5, 3, 4, 3, 5. So these are the ordered pair in the product set A cross B. Okay, now from there we can find various type of relations. How many relations are there? Yes, how many relations are there? The total number of relations equals to 2 to the power mn, the number of subsets. Okay, so we write sum of the relations. Suppose R1 is one relation from the product set. Suppose it is 1, 4, 2, 4 and 3, 4. Suppose somebody write R2 equal to 1, 5, 2 5, and suppose it is 3 4 and 3 5. Suppose somebody write R3 equal to the relation number 3, it is 1 4 2 5 3 5 1 5. Okay, so in this way we are writing various type of relations. Now my dear students, we are telling that function is what? Function is a relation, but every relation is not a function. That we are already discussed in our first year classes. ତମାନଙ୍କର ସମସ୍ତଙ୍କର ମନ ଅଛି ନା ପିଲାଏ? ଫଙ୍କସନ୍ କ'ଣ ନା ଫଙ୍କସନ୍ ହେଉଛି ଗୋଟେ ରିଲେସନ୍, କିନ୍ତୁ ପ୍ରତ୍ୟେକ ରିଲେସନ୍ ଗୋଟେ ଫଙ୍କସନ୍ ନୁହଁ। ହେଲେ କ'ଣ ଏକ୍ସଟ୍ରା କଣ୍ଡିସନ୍ ଅଛି? ରିଲେସନ୍ର କ'ଣ ସ୍ପେଶିଆଲିଟି ଥିଲେ ଫଙ୍କସନ୍ ହେବ? ମନେ ପକେଇଲ ଦେଖିବା। ଓକେ, ମନେ ପଡ଼ୁନି? ଓକେ, ଆଇ ୱିଲ୍ ଟେଲ୍ ୟୁ that what is the condition imposed that the relation is called as a function. Function रे कौन खासियत थाए जे से रिलेशन को आमे फंक्शन बोली कहू। फंक्शन रो कौन स्पेशलिटी अछि? You see the conditions. Next I will going to tell you that the conditions imposed on relation. Relation रे कौन condition रहिले से फंक्शन बोली कैटेगरी रे आसी परिबो। As we told that function is a relation, but every relation is not a function. ସେଇଟା ବର୍ତ୍ତମାନ ଆମେ discussion କରିବା। Okay, so you see, next I am writing the conditions. Keep these examples at here. I am writing it in a side. Conditions for a relation, conditions for a function. Okay, conditions for a function. So what are the conditions? And then we will go to the examples and we will verify which relation is a function or not. Okay, so these are the basic concepts. So you see, any function or any relation f from A to B, that means it is derived from A cross B. Okay, any relation f from A to B is called as a function. Is called as a function if the first condition is the domain of the relation, that is the relation is named as a, should equal to the set A. The second condition is if the ordered pair AB belongs to F, means A is related to B on the same relation, that implies AC does not belonging to the same relation, means A cannot connect with more than one element. Okay, A cannot connect, a single element of the domain set cannot connect with more than one element of the codomain set. Okay, so that is the rule, that is the condition imposed for a relation to be a function. Function हेबा पई हेले relation को ए दीटा condition कौन करिबा को पड़िबो, satisfy करिबा को पड़िबो. Okay, now you see what I told you, I am checking it by these examples. Okay, you see these are the relations. Clear? Okay, undoubtedly they are the subsets of the product set, so they are called as the relations. But those relations can be called as function. Let us check. Clear? Let us check whether those relations are called as function or not. Okay, my dear students. So you see this relation R1. You see, first of all, what are the conditions imposed? The conditions are the domain of the relation should be equal to set A, means all elements of set A should be involved. Here you see the domain of that relation equal to set A. Yes or no? Okay. Next of all, if A is related to B, then A can't be related to C. You see here 1 is related to 4, so 1 is not related to another element. Many other elements may be related, but one cannot have two images or two connections. So you see, one is related to 4, and you see in the total relation, one is not connected with any other element. 2 is connected to 4, and you can see 2 is not connected with any other element. You see 3 is connected to 4, and 3 is not connected with any other relation. So this relation is called as function. Now whether this relation is a function or not, can you verify? Let us check it. Yes, you are correct. This relation is not a function. A relation ta function hoboni. Kahinki hoboni? The domain is not equal to set A. Yes, the first condition is satisfied. The domain equal to set A, but the second condition is not satisfied. Why? Because this element 3 have two connections. 3 is connected to 4 and 3 is connected to 5. 3 4 सहित भी कनेक्शन करिछि, 3 5 सहित कनेक्शन करिछि. सो गोटा एलिमेंट दि जन को सहित जदी कनेक्शन कला, दि जन को सहित जदी तार से रिलेशन से ऑर्डर पेयर आमे पाइबा, that relation can't be called as function. Okay, so this relation can't be called as function. Okay, next, whether the relation third relation is a function or not, my dear students, please check it whether this relation is function or not. Okay, please verify. Verified. You see, this relation is function or not? Yes, you are correct, my dear student. This relation is not a function. Why? Because this element 1 is connected twice. Okay, this element 1 is connected twice. So this relation is not called as a function. Okay. So this one is called as a function only, whereas this and this are not the functions. Clear? Now let us, as we are writing it as a what? As the definition is written at here. Now let us go for the diagram. Diagrammatically how we verify it. Okay? So you see, imagine whether which of the relations are functions or not. Now you tell me, I am going to show it to diagrammatically also. You see, in diagrammatically, what we do, we take two sets. Okay, so we are taking it through an example. Check this type of diagrammatically questions are sometimes asked in your exams. Check whether the following diagrams represent function or not. Represent function or not. Okay, so for it what we do, we have this type of pictures are there. Suppose one is set A and another is set B. Okay, and suppose it has 1 2 3. Suppose it is 4 5 6 7. Now suppose it is given like this. One is connected to 4. The arrow mark shows the connection. Now suppose one is connected to 5, 2 is connected to 6, 3 is connected to 7. Okay, suppose it is the picture 1. Now suppose we are going for the second net, and then we will check whether which of the connections, which of the relations from A to B are functions or not. Suppose it is 1 2 3 4, and suppose it is 4 5 6 7 8. Okay, one is connected to 4, 2 is connected to 5, 3 is connected to 6, 4 is connected to 8. Suppose it is the diagram 2. Okay, now in this way we proceed and we can check suppose we will take another one and you have to verify whether this diagram are representing function or not. Suppose it is the set A and it is the set B. Suppose it has elements 1, 2, 3. Suppose it has elements 4, 5, 6. 1 is connected to 6, 2 is connected to 4. Okay. So now we will check whether these relations diagrammatically represented are functions or not. Okay. So you see the first one, is it a function? Which of them are functions or which of them are not functions? How to verify, my dear students? Can you verify? Yes, I know you can verify. So please think about it. Is the picture 1 is a function? Yes, the picture 1 is not a function. Your imagination is 100% correct. This picture 1 is not a function. Why? Because 1 is connected twice. 1 is connected twice. So it violates the condition 2. The condition says that if the elements of the domain set is connected to a single element of the codomain set, then it can't be connected twice. So here 1 is connected twice as the functions are from A to B, the arrow mark represents. Okay, as the arrow marks represents that it is connection is done. So this connection, this relation is not called as a function. Okay. Now is the second representation is a function? You see? Yes, this second one is a function. Why? Because both the conditions are satisfied by this diagram, by this relation. How? You see, all the elements are involved at here. Means domain of this relation is equal to set A. All the elements are involved. Yes or no? The second thing is, no element is connected to twice. गोटे एलिमेंट एक रु अधिका थर कनेक्शन करिनी. सो यही भलिया रिलेशन को, यही भलिया डायग्राम को आमे फंक्शन कहि परिबा. ओके, diagrammatically we can check it also. Now we will move to the third one, that is it a function? Yes, it is not a function. Why? Because the domain is not equal to set A. Though the second condition is okay, but the first condition, all elements are not involved. All elements are not taken part in this relation. So this relation can't be called as a function. So here only the diagrammatically representation in 2 is called as a function, whereas others are not called as functions. The second one is only called as a function. Okay, so this is the way to check that whether the relations are functions or not diagrammatically. We can verify it in a clean manner through diagrammatically, through picturically. Also we can check it. Okay, my dear students. Now we are going to read something. So till now what we read? We read the definition of function, that as all glitters are not gold, similarly all relations are not functions, but function is a relation. Okay, so function is a relation, but every relation is not a function. What are the conditions? Yes, the conditions are the domain should be equal to set A. Next condition is a single element has a single image. Okay, all elements of the domain set are involved. Clear? So with this, these are the some basic concepts of functions. Okay, and we know that what is the domain set, what is the codomain set, and what is the range set. मन अछि ना पिले, domain कोन, codomain कोन, and range कोन. Okay, just we will go for a quick look again. What is the domain, what is the codomain, and what is the range of a function. Okay. So now आमे बर्तमान कौन डिस्कशन करवा बर्तमान आमे फंक्शन रो फास्ट जानि सारिला परे फंक्शन रो कंडीशन जानि सारिला परे फंक्शन को एग्जांपल थ्रू रे देखिला परे नाउ वी आर गोइंग टू डिस्कस अबाउट द व्हाट वी आर गोइंग टू डिस्कस अबाउट द डोमेन कोडोमेन एंड रेंज ऑफ ए फंक्शन ओके सो वी विल राइट डोमेन कोडोमेन एंड range of a function. Okay, domain, codomain and range of a function. So if f from A to B means it is from set A to set B. It is your set A and this is your set B. Okay, and it is the function f. F is from A to B. It transposes the elements, it maps the elements of set A or it connects the elements of set A to set B through a certain relation. Okay, so if f from A to B is a function, then set A from where we are taking the elements means where all the elements of A are involved is called as the domain set. Set A is called as domain of F. Okay, and you know in short it is written as D of F, domain of F. Okay. Next, what is the set B? Yes, set B is called as what? Codomain of F. Okay, set B is called as codomain of F. Next, now what is your range? How to get the range? The definition says set of all images of the elements which are involved in the function means what? As we are writing, for example, I am showing it in an example. You see, suppose it is 1 2 3 4 the set A contains and set B contains 5 6 7 8 9 10. Okay, so 1 is suppose connected to 5, 2 is connected to 6, 3 is connected to 9, 4 is connected to 10. So those elements are involved in that connection or in that relation. Here 1 has the image 5, 2 has the image 6, 3 has the image 9, 4 has the image 10. So say image मानो को नहीं की जो सेट आसीबो सेमानकर कलेक्शन को नेकी जो सेट आसीबो सेही कलेक्शन सेट को we are calling it as the range. Okay, so what we write? Set of all images of elements under F is called as range of F. Range of F or R of F. It is noted like this, range of F. Okay, range is also called as image of F. Okay, that is, if f of A equal to B, then B is called as image. And those type of images, if we collect them, that collection is called as your range. Okay, so that is called as range. now you know range is where? So range is in the codomain. So we can say as a note, range is a subset of what? Of codomain. Range is a subset of codomain. So this is some of the basic concepts of the domain, codomain and range of a function. Okay? Now my dear students, somebody asks you that how many functions are there? How many functions are there? Let us verify the total number of functions. Clear? So next we will discuss about the total number of functions. So this is about the domain, codomain and range. So again I will give you the information. If the function is from A to B, if the function is at here you can see the function is from A to B, then the total set A is called as what? Is called as the domain. Clear? The total set B is called as what? Is called as codomain. And those involved elements, that collection is called as range. Okay? Those involved. So if somebody asks you what is the range? The set containing 5, 6, 9, 10. Because only those 4 are involved. We don't need to write the extra 7 and 8. Okay? If you take the total one, the total is called as codomain. Clear? But always remember, in a function, all elements of the domain set should going to be involved. ସମସ୍ତେ କ'ଣ କରିଥିବେ? ସେଟ୍ A ର ଯୋଉଠୁ ଫଙ୍କସନଟା ମ୍ୟାପିଂ ହେଉଛି ସେଇ ସେଟ୍ର ସବୁ ଏଲିମେଣ୍ଟ କ'ଣ କରିଥିବେ ସେଥିରେ? ନା ପାର୍ଟିସିପେଟ୍ କରିଥିବେ. ଓକେ, ଦ ସେଟ୍ ଅଫ୍ କଲେକ୍ସନ୍ ଅଫ୍ ଅଲ୍ ଏଲିମେଣ୍ଟସ୍ is called as the what? Is called as domain of the function. So this is about the domain, codomain and range of a function. Clear? Now we'll move to the total number of functions. Suppose here we will verify. Let this picture, we will keep this picture as it is. Okay. Somebody asks you that how many functions are there here. So how to know? You see what is remember about the counting. Okay. You see in a function what we have to do? We have to connect the elements of the domain set. So for connection of one, how many elements are involved? So it is equal to how many elements are there in B? So it has 6 elements. So it has 6 number of choices. Then for 2, again it has how many choices? 6 choices. For 3, how many choices? 6 choices. For 4, it has again 6 choices. So the rule says, okay, the rule says, as per the principle of counting, the rule says total number of functions. Total number of functions. If cardinality of A, if f from A to B is a function, and cardinality of A equal to P. Cardinality of A equal to P. Cardinality of B equal to Q. Okay, cardinality of B equal to Q. Then total number of functions. Total number of functions equal to, what is the total number of functions? It is equal to Q to the power P. Okay, total number of functions equals to how much? Q to the power P. Okay, that is why I am telling that for 1 how many choices are there? 6 choices. For 2 how many choices? 6 choices. For 3 how many choices? 6 choices. For 4, how many choices? 6 choice. Okay. So as per the principle of multiplication, okay, remember the principle of multiplication, the total work can be done in how many ways? We have to multiply the individual options. So it is 6 into 6 into 6. So it is equal to how much? It is 6 to the power 4. Verify with it. You see here cardinality of A equal to 4, cardinality of B equal to 6. So the total number of functions from A to B is equal to 6 to the power 4. Okay. So এইঠু আমি জানি পাରୁছে যে ଆମର function সংখ্যা কেতে হবো? It is cardinality of B to the power by cardinality of A, which is written also like this, cardinality of B to the power cardinality of A. Okay. So in this way we are able to get the total number of functions. Okay. So somebody may ask you, these are the numerical questions in some exams, that if cardinality of A equal to 3 and cardinality of B equal to suppose 2, find the total number of functions from A to B. Therefore here total number of functions equal to how much? Total number of functions equal to cardinality of B to the power cardinality of A. So it is equal to 2 to the power 3, which is equal to 8. Okay. So in this way we are able to get the total number of functions. Clear? You see the total, how to get the total number of functions. Please check it. Okay. So now up to it, these are the basic concepts, and we are realizing that we are acquainted now with functions and domain and range and codomain of a function and the total number of functions, how to count the total number of functions. So these are the basic concepts. Okay, my dear students, next move to the topic which is very vital from your exam point of view, from your second year point of view, that is about the types of function. Okay, so that we have to discuss, that is very vital for you. Okay, very important, and as per your exam point of view, what is that concept? That concept is types of function. Already we have discussed about the various type of functions, that means their nature, that means about the logarithmic function, about the polynomial function, about the modulus function, about the characteristic function, etc., etc. in our previous classes in first year. Now we will go for the some other type of functions. Okay, you see what? So next we will write give the heading different types of functions. Okay, so next we will write, give the heading, and we will read about different types of functions. Okay, in different types of function, first of all we are going to read about the one function. Okay, according to their connection, the functions are categorized in different way. So the first one is about the one function. Okay, what the one function says? This function says, let us elaborate, we will elaborate this concept through a example. Okay, you see, first we will go for an example, then we will go for a definition. You see, suppose this is set A and suppose this is set B. Okay, it has the elements 1, 2, 3. It has the elements 4, 5, 6. So you see, 1 is connected to 4. So if 2 is connected to 5 and 3 is connected to 6. So you see, the single element of set A is connected to a single element of the codomain set. Every single element is connected to a unique and different element of the codomain set. If that is the condition, then the function is said to be 1 1. से समय रे से फंक्शन टी को कौन बोली कहाजिबो ना 1 1 फंक्शन बोली कहाजिबो. Okay, so next we are going for the definition of 1 1 function. Okay, so the definition says any function f from a to b, f from a to b is said to be 1 1, is said to be 1 1 if x1 comma x2 belongs to a such that x1 comma x2 belongs to a such that f of x1 comma f of x2 belongs to b, where f of x1 equal to f of x2 implies x1 equals to x2. We can understand it through like this, or we can say also if x1 not equal to x2, that implies f of x1 is not equal to f of x2. Okay, in this way also we can recognize the what type of function 1 1 function. 1 1 function को आमे एई भलिया मध्य बुझी पारिबा. कोन the rule says if f is from a to b, if f is function defined from a to b is said to be 1 1. This function is said to be 1 1 if the elements belonging to the domain set, if the elements belonging to the domain set having the images in the codomain set, and if the images are equal, then the original elements are not distinguished, they are also equal. Or if the original elements, if the domain elements are different from each other, they are not unique with each other, they are distinct from each other, then their images are also distinguished, are also separated, are also different from each other. जदि इमेज समान हबो तेबे एलिमेंट मध्य समान हेतिबे, बा एलिमेंट समान हेतिले इमेज समान हबो. जदि इमेज समानकर अलगा अलगा तेबे एलिमेंट मध्य कोन अलगा अलगा. मीन्स फॉर ओनली वन there exists one. Okay, that's why it is named as 1 1. जनक पाई जने. Okay, for only one element, for a unique element there exists a unique image. Okay, so under that condition the function is said to be what? 1 1 function. Okay, now we can check through diagrammatically. You see clearly this diagram shows that this is an example of what type of function. This is very fine to say that yes, this diagram is representing a what type of function? A 1 1 function. Okay, 1 1 function को a diagram कौन करुची? Represent करुची. Now we will move to some other diagrams and we check whether the functions are 1 1 or not. बाकी function 1 1 हेबे ना नहीं, वर्तमान हमें checking करिबा. Okay, let us check it. So what I will do, I will take some more pictures and some more diagrams are there and we'll check whether the functions are 1 1 or not. Okay. So what we do? Suppose we are taking this is set A and this is set B. Okay. Suppose it has elements 1, 2, 3, 4. Suppose it has elements 5, 6, 7, 8. These connections are like this. This is the picture 1. And next we will go for the picture 2. You see, so can you tell me which of the following picture, this is suppose picture 1 and this is your picture 2. So can you tell me which of the following pictures is representing a one-one function? Okay, clear? We are very much clear that this diagram representing in picture 1 is not representing a one-one function. Why? Because you see these two, okay, these two are two different elements. 2 is different from 3. They are belonging to set A, means the domain set, but they are not having distinct images. They are having a single image. Okay, so in this case, if the distinguished elements are having a single image element, the function is not said to be one-one. Okay, the function is not said to be one-one. But here you see what happened. You see the elements are distinguished from each other, and you see their images are also distinguished. 1 has the image 5, 2 has the image 8, 3 has the image 9, 4 has the image 6. So if the elements, distinguished elements are having distinguished images, that function is said to be what type of function? It is said to be one-one function. Clear, my dear students? So this is about the pictorial representation of what type of function? It is pictorially represented the one-one function. Clear? Now we see some more results, some more information about the one-one function. What? The first information is one-one function is also called as injective function. Is also called as what type of function? Injective function or injection. Okay, one-one functions is also called as injective function or injection. Clear? Now the second says if cardinality of A. Now we are going to find the total number of one-one functions. The rule says if cardinality of A equal to cardinality of B equal to P, means both are having same elements. As you see here, set A contains how many elements? 4 elements, and suppose set B contains 4 elements. Suppose both are having same elements, then how many number of, if the functions are going to be constructed, then how many of them are one-one? If both domain set and codomain set are having the same cardinality. So the rule says if cardinality of A equal to cardinality of B equal to P, then total number of one-one function equal to P factorial. Okay, it is equal to how much? P factorial. Next, I am going to tell some other results. Make those as note. Okay, please make a note of it. Next, you see the rule says if the domain and the codomain are having different type of cardinality, then how many total number of one-one functions can be constructed? That we are going to verify. Okay, so till now what we read? Till now we are reading about the definition of a function. We are reading that how many functions can be constructed, under what condition a relation is called as a function. Okay, so these are the some basic knowledges we are learning now. Now we are moving to the one function, and we are checking that how a function is one. When a function is one, if the different elements belonging to the domain set have different images in the codomain set. Okay, if the different elements of the domain set having different elements or different images in the codomain set, then that function is said to be one. Okay, so now we are moving to the total number of one functions if they are having different type of cardinality. So the rule says if cardinality of A equal to P, suppose cardinality of A equal to P and cardinality of B equal to Q, if cardinality of A equal to P and cardinality of B equal to Q, then total number of okay one functions then total number of one functions from A to B means f is from A to B. Okay, that is represented here from A to B equal to 0. That means no one function can be found under what condition? If P is greater than Q. We will elaborate it through diagrammatically. Later on we will elaborate it. So it is equal to 0 if P is greater than Q, and it is equals to, and this is equals to Q factorial by Q minus P factorial. It is equals to Q factorial divided on Q minus P factorial if P is less than or equal to Q. Okay, in this way we are able to get the number of functions, total number of one functions. Okay, now we will show it through examples. You see through diagram. Suppose I have set A. I am going to show you that why it is 0. Okay, let us go to that concept. And suppose it is set B. So the rule says the total number of functions f from A to B equal to 0 if B is greater than Q. You see, suppose it has 5 elements. Suppose it has 2 elements. Okay. Now suppose I connect 1 with 3. Then suppose 2 is connected to 2. Now these 3 are. If I connect them to some other element of set B, either with 2 or with 3, I can get a function. But it is not 1. Okay, I can get a function. Again I am repeating. I am able to get a function. But this is not 1. Okay. So for 1, what is the condition? The condition is if the images are different, the elements are different. If elements are different, images are different. Okay, as you see, 1 has image 3, 2 has the image 2, but for what about for 3, 4 and 5? They are not having any image. Okay, so this type of function, that's why the total number of one function is equal to 0. Okay, my dear students, so this is about the one function. Now if it is larger, suppose it has, we will go to the second one. Suppose it has 3 elements, and suppose it has 6 elements. Okay, let it is set A and it is set B, and f is the function from A to B. So for connection of 1, you see 6 elements are there. For connection of 2, and if it is 1, it has 5 number of elements. Then for 3, it has 4 number of elements are existing. So it has the choices here. That why the total number of choices, the total number of possible 1 functions is written in the form of q factorial divided by q minus p factorial. এই ভଳିଆ rule দ্বারা ଆମେ କ'ଣ କରିବା 1 function ର ସଂଖ୍ୟା ବାହାର କରିପାରିବା that କେତେ ନମ୍ବରର 1 function ଆମର construct ହେଇପାରିବ. Okay, this is about the some basic definitions of 1 function. Clear? So next we will go for the another function which is called as onto function. Okay, this is another information of onto function. Okay, what the onto function? Now we will move to the second type. First we read about the 1 function. Now we are moving about the onto function. Okay, the onto function says, first of all, onto function is also called as surjective, or surjection. Onto functions are renamed as surjective or surjection. Okay, this is it has the synonym. Onto function को आमे कौन बोली कहि परिबा surjective function मध्य कहि परिबा बा तार अन्य ना कोन, that is also called as surjection. So यार definition कोन? Now we will go to the definition of onto function. If f from a to b, if f is a function from a to b, is said to be onto if for every y belongs to b, if for every y belongs to b, there exists a unique x belonging to a such that f of x equal to y, Okay, means what? Means if f is from a to b, so suppose this is a and this is b and this is the function f. Okay, so whatever the element belongs to b, till now we are not considering on the codomain set, but in an onto function we are considering the what? Codomain set. Means every element belonging to the codomain set, for every y belongs to b, there exists a unique image x. Suppose it is y, then for every y belongs to b, there exists a unique image x or the pre-image x such that f of x equal to y. Okay, or in other words, if f is onto, then range f equal to codomain of f. The range is equal to the codomain. The range set is equal to the codomain set. Then that function is said to be onto. Clear? So this is the, later on we will show it by more examples. Okay, now we are moving to some of the diagrammatical examples of onto function. So this is the basic definition of onto function, and now we are moving with to some examples. Okay, you see with more examples. Suppose it has set A and it is set B and f is function from A to B. Suppose it has 3 elements and it has 7 elements. Sorry, it has 4 elements, 4, 5, 6 and 7. So you see one is connected to 5, 2 is connected to 4, 3 is connected to 6. So is it a function? Is it a function? No, it is not a function. Okay. Now, so under what condition? Here all elements are involved. You see, all elements are not involved. Suppose I write 3 is again connected to 7. So it is not a function. But because why? Because 3 is having two different images. So now for onto function, you see what happened. Suppose it is your set A and it is set B, and suppose it has 1, 2, 3, and it is 4, 5, 6, 7, and 4, 5, 6. Okay, so you see, suppose 1 is connected to 6, 2 is connected to 5, 3 is connected to 4. Okay, so this function can be called as onto function. Why? Because all elements of the what? Of the codomain set are involved and they have a pre-image in the domain set. 4 has the pre-image 3 such that f of 3 equal to 4 if f is the function from A to B, and similarly f of 2 equal to 5 and f of 1 equal to 6. But if all elements are not involved, as we see in the previous class, all elements are not involved. What I show at there, 1, 2, 3 is there, and suppose it is 4, 5, 6, 7. Okay, and f is function from A to B. Suppose 1 is connected to 4, 2 is connected to 5, 3 is connected to 7. So this is a function, no doubt, but it is not onto. Why? Because the codomain is not equal to the range. But if they are equal, if the codomain is equal to range, then the function is said to be onto, otherwise not. Okay, so my dear students, this is the basic concept of onto function. The onto function says that for every y belongs to B, there exists a unique image element x belongs to A such that f of x equal to y. Okay, so with this basic concept, we are able to learn the onto function. Okay, now we are going to check out how many of the total functions are onto, how many functions are onto or can be constructed as a onto function. Okay, so first of all, we go for the total number of onto functions. We are going to count with the empirical formula is there. So I am going to tell you. So next is, so if, next I am going for some of the observations. If f from A to B is not an onto function, is not an onto function, then it is called as, then it is called as an into function. से function को कौन कहाजिबो? Into function कहाजिबो. Okay, next thing is, if f from A to B, if f from A to B is an onto function, if it is going to be an onto function, then the condition is cardinality of A should be greater than or equal to cardinality of B. Then cardinality of A should be greater than or equal to cardinality of B. Otherwise, if this condition is not satisfied, then the function is not said to be onto. Se function ko onto kuhajai paribo nahi. Okay. Now we are going to find the total number of onto functions. The rule says, how to get the total number of onto functions? The rule says, if cardinality of A equal to P, if cardinality of A equal to P and cardinality of B equal to Q, if cardinality of A equal to P and cardinality of B equal to Q, then total number of onto functions. Then you see total number of what? Onto functions. It is equal to, the rule says it is equal to sigma summation. It is equal to sigma summation R equal to 1 to Q. So that means we have to proceed from 1 or to Q, and it is equal to minus 1 to the power Q minus R. You see very carefully, it is sigma summation. That means we are going to sum the results. So it is sigma summation R equal to 1 to Q minus 1 to the power Q minus R QCR R to the power P. And when this rule is going to be applied, if P is greater than or equal to Q. If P is greater than or equal to Q. And the result says it is 0, as I told you. If, under what case it is equal to 0? If P is less than Q. Okay. Under this rule, we are able to get the total number of onto functions. Again, I am writing how to get the total number of onto functions. You see, the rule says, I am cleaning the board and I am writing again for you the total number of onto functions. Okay. The rule says, again I am repeating the same thing for your clarity. You see, if cardinality of A equal to P, okay, and cardinality of B equal to Q, then total number of onto functions equals to sigma summation R equal to 1 to Q minus 1 to the power Q minus R QCR R to the power P. Okay. So this is the rule is going to be applied when it is P is greater than or equal to Q, and it is 0 when P is less than Q. Okay. So I am cleaning this one. So this is all about the information to count the total number of what? Onto functions. Okay. My dear students, please go through it and see how we are able to get the total number of onto functions. So in this way we are able to get the total number of onto functions, and when cardinality of A equal to cardinality of B, okay, that is very easy. If we put it there, that is equal to P factorial. Next I am writing, if cardinality of A equal to cardinality of B equal to P, then, or that means P is equal to Q. Okay, then total number of onto functions equals to P factorial. Okay, from A to B. So in this way we are able to get the total number of onto functions. So my dear students, these are the some of the basic concepts of a function when the function is said to be 1, 1, when the function is said to be onto, and how to count the total number of 1, 1 functions and the total number of onto functions. Next we will move to some other basic concepts in our next class. So, okay, so till here now I am concluding it here, and we will move to our next topic of discussion in the next class. Okay, so my dear students, thank you to all.